We are back once again to extract value from the desolate desert that is LeetCode. That's probably too hardcore. We are back once again. We are being bullied by a binary problem, by a binary type of problem, but nonetheless, we have even greater pressing news, okay? I recently finished Cyberpunk EdgeRunners, and this story, wow. Wowzers. So, I watched a show on Netflix. If you haven't heard of it, it's probably to do with the Cyberpunk 2077 game, which I believe was written with many bugs and issues, and I wasn't very interested in the game in the slightest, to be honest, but a lot of the visuals looked cool, and the gameplay I wasn't super excited for either, but I guess I just wasn't really tapped into the game. But the show on the other hand locked me into a suit, or locked me into a cart on a roller coaster, and it was just quite a ride. So much so that after I finished the ride, I was left contemplating if a life could be lived outside of the roller coaster itself. Just crazy. I think sometimes the ability for stories to just kind of transport you to another place is just very interesting. And I think it was just so inspired. Like, a lot of the stuff, there'll be no spoilers, by the way, but a lot of the team, you can just tell there's just a lot of love in the show. There's just a lot of intent to tell a good story. There's a lot of not safe for work stuff in the show, but nonetheless, just an incredible ride. So it just really made me rethink a lot of things. I think sometimes I will watch, I have some rib issues, but I have, sometimes I'll watch some of these pieces of media, and I think they can make you experience such a breadth and depth of emotion, whether it be a book or a movie or just a really good soundtrack, or when it all comes together. I think you can experience such a depth and breadth of colorful emotion that I think after the completion of the show, you're left wondering, or I guess you're left questioning why you lack this colorful emotion in the day-to-day. Maybe that's just the mundanity of life. You show up, you do some stuff, go to sleep, you do the same thing every day. Or maybe, it's hard to know, but the show really had me thinking after I was finished. It really made me thinking about what one wants to extract from life. But it's just very interesting. But I'd be interested to see if anyone else has watched the show, what they think about it. As always, I think, we're watching these things, and it's like, you're extracting some part. Hopefully there's enough space for you to see your own human condition in the story. I'm wondering if the reason why I think it's so profound is because maybe it touches on a soft spot within myself. But it's just very interesting because obviously, there have been other shows as well where I've thought like, oh, this is very interesting, or, it makes me think. But it may not make someone else think. And I don't think that's because they don't think the show is as good. I think just sometimes like you might see something, you might see a piece of yourself reflected in like a piece of media. And I think for another person to find it, I guess, profound in the same way, maybe they need to be missing that piece as well. Or maybe they need to be seeking it. But maybe if someone already has it, maybe they might not see exactly, how you're seeing it. If that makes sense. I don't know if that makes any sense, but I guess what I'm saying is I thought it was a really interesting show. And now that I'm finished, it's really left me thinking what has me questioning what I would like to extract out of this life. It reminds me of the book. It's called Tribe. I don't remember who it's by, but it's about tribes basically, and how we used to be some apes or some monkeys, and just about how things have changed since then, and how a lot of the things that maybe we found solace in as ape people that maybe we no longer have. For example, one example in the book I think was, I'm gonna butcher a lot of these things. I'm just kind of paraphrasing it, and then there's some copy and read errors, so it's gonna come out a little messed up. But read the book if you'd really like some better insight. But there's one thing that I remember that's sticking out. Like the author mentions that we used to sleep a lot as in groups, but we don't really do that. For example, most of the times when you grow up, most of the times when you grow up as a kid, you end up sleeping in another room, or pretty much away from your parents, or pretty much, you know, just separately, right? And it's just very interesting because I think what they were saying is that most of like humans back then, you always slept in a group, so you always felt like, you know, a sense of like safety or solace, I guess. But it's just very interesting because I guess I'm trying to tie it back to what I was saying before, in that, yeah, I think things have just sort of changed. Dang, I lost where I was going with this. Oh, yeah, reflecting on question. Oh, yeah, I remember now. Reflecting on questions that, you know, we may not have to answer today. For example, we're going back in time with the sleeping in groups thing. A lot of us slept in groups, apparently, as 8 people, and this, you know, gave us a lot of things that apparently we did this for a very long time. So we're very much evolved to sort of like that sort of thing, or feel safety in groups and stuff like that. So if you've ever gone camping and you're all sleeping very close together, you might be in the middle of nowhere, right, where you have pretty much the greatest sense of danger, I guess potential danger, you know, rather than, you know, sleeping in your house, but you can still feel relatively safe. And I guess the question of that is whether that is like a biological mechanism, like, you know, we evolved to kind of just be like, oh, in groups and feel safe and kind of sleep together and stuff like that. But, you know, that's kind of not a thing we do. So most of the times, you know, when kids are growing up, they're growing up sleeping alone or in separate rooms. That's besides the point. Just to tie it into another point about the whole point of the tribe book is basically saying we used to do things when we used to be monkeys or 8 people that, you know, we just don't quite have access to. And one of those things they asked about was, because life was so perilous back then, the question of what would you die for? Who would you die for? And what are the ideas or beliefs you would die for? Was a question you had to answer relatively frequently, probably daily, you know, because the environment was so treacherous. We didn't really have many tools. Things weren't that good. So the author, I think, tries to get at the point that, like, oh, because we had to answer these questions so often, you know, people felt, you know, a great sense of content or purpose, you know, like, because the environment was so treacherous, you found that purpose in surviving. You might answer a question and be like, I'm surviving for this person, I'm surviving for this idea, or I'm fighting for this thing. Whereas a lot of, you know, I don't want to say a lot or speak so definitively, but I think that question the author postulates is largely removed from day-to-day society. So you never really have to, going about your day-to-day life, you never really have to answer the question, who would you die for? Because the probability of death, you know, depending on where you live, of course, you know, might be a first world take, you know, is just not that high. And so it's just very interesting with just things like lack of purpose. To mention that, and also the thing with the sleeping, is just to say, somewhere along the way, we might have lost some things. But I think sometimes through media, I feel like it can be made glaringly obvious sometimes, I guess, what we're missing. So all this to say, the show was very, very cool, and I'm starting to think maybe I should collect my thoughts before I start speaking. But it's just very interesting, and I think the show left me thinking, you know, what would one die for? You know, I guess watching someone, or, you know, in a show or medium or book or whatever, have overwhelming purpose or overwhelming group cohesion, I think it's hard not to maybe it's the contrast between the colorful emotion you experience during viewing and the, I guess, necessarily dry or gray tint that the day-to-day definitely does have. So maybe that, I guess, being cognizant of the delta or the difference between those is just very, very interesting. That is besides the point, to say that a lot of this mindset is definitely transient, but it's just interesting to see, interesting to think about. Very interesting. But I'd be curious to see what other people thought about the show. Let me see. I'd also be interested to see what other people thought about LeetCode. So we're back once again with LeetCode. We have some questions here. I did pre-read Niall's question, but I think we're running just a little bit low on time, so I'm gonna write a comment. But Aurelius mentions To remap on Windows, I use sharp keys. This is actually a good point. We actually needed this software. So I'm actually I'll probably download it and remap, because it is a bit frustrating not being able to pretty much use this computer like a Mac computer. But nonetheless, we have 60 minutes. And yeah, the show's great, so you should check it out. Let me know what you think about the show. And yeah, we have another dollop of misery to work at today. So let's continue working on this binary problem that makes little to no sense, and we'll try and take a closer look. So you're working on this problem: convert a number to hexadecimal, give an integer num, return a string representing its hexadecimal representation. For negative integers, 2's complement method is used. All the letters in the answer string should be lowercase letters, and there should not be any leading zeros in the answer except for the 0 itself. Note, you are not allowed to use any built-in library to directly solve this problem. Basically, converting a number to hexadecimal, input is 26, we convert it to 1A. The one catch, though, is that we also have the range of negative to positive numbers, and we know that we're dealing with signed numbers because we have 2 to the 31 bits as range, with 1 bit being used as the sign bit. So we have -1 -1, and our output is supposed to be FFFFF when converted to decimal. I actually wrote a note: tomorrow don't try and flip the bits, just read the negative number using the MSB as the sign. What did I mean by that? Tomorrow don't try and flip the bits, just read the negative number using the MSB as the sign. Calculate its value, convert to hex. So num -1 tomorrow don't try and flip the bits, just read the negative number using the MSB as the sign. Calculate its value, convert to hex. So when we're just converting 26 to hex, we get the right answer. When we convert negative numbers, we get the wrong answer. I think -1 is already represented in the way that we want it to be. Maybe you can't represent negative numbers in hex. Isn't that also a strange thing? Because -1 is coming out as FFFF. Maybe I meant just read the negative number using the MSB as the sign. So when I ran the number, the output if we subtract 1 and flip the bits, you get 1, which makes sense because that would be the 2's complement representation, and it would equal 0. Maybe we need to just read. I think I see what I'm saying, or what I meant. I think we just need to read the hexadecimal value. No. the number -1 is already represented in the way that we need it to, I think, because -1 in 2's complement, or -1, to get that we would pretty much have 1, right? And then we'd flip all the bits and then add 1. So the number is already represented the way we want it to. We just have to convert it to base 10, I think. So what if we comment this out and just do if num is less than 0, we'll just say num equal it's not that it's not in base 10. What intermediary, it's the number is represented as -1. We just need the binary version of the number. It would just make a function called calc binary, and we'll pass in num. And it's just going to take num, which is a number, and return a number. And what we're just going to do is just read the binary value. So we're just going to say let value equal 0, and then we're going to return value in the end, and we're just going to calculate it as normal. So we're going to let power equal to 0. We have to go in reverse, so we're going to let I we're going to want to do this 32 times, basically 31 times. No, 30. Let's just print the bits first. I is less than 32, I plus plus, and then to print it, we're just going to say console.log num and 1. Otherwise, we'll print 0, and then we're just going to shift it over 1. So I think we should just be able to calculate the values. It's all set to 1, which sort of makes sense. I think we'll skip the last bit, stay within the range, because the last bit, or the most significant bit, would be the sign, and we're going in reverse. And we'll say value plus equal num bitwise and 1 times 2 to the power. And this, I always forget to add 1 to the power afterwards. So here you have 1, 2, 3, 4, 5, 6, 7 Fs. Here, we should have 8 Fs. Maybe we shouldn't skip the last bit. Now the answer is too large. We have 8 Fs here. 1, 2, 3, 4, 5, 6, 7, 8. Might be easier to see what's happening if we just use a different value like -10. So we have 0, 1, 1, 0. 1, 2, 4, 2, 4 be 6. 16. So we have 16, right? -16. I mean 2 to the 1, basically -16 plus 6 would give you -10. Maybe the positive value, maybe the negative, wait. This equals -10 in binary. How are they getting FFFFF7? I mean FFF, there's just multiple Fs than 6. How is that possible? It looks like they're just... Feels like they're just looking at the bits as a positive only. So I wonder if we just did num equals no. No, don't tell me this works. Oh, okay. I forgot the edge case of 0. I keep forgetting we're returning a string. num is 16. And expected 1, 0. 16 converted to hex be 1, 0. Now we'll keep this code for now. Maybe this version doesn't make any sense. We had a similar problem with that other problem. We had a similar problem with that other problem. It had to do with, I think it was Excel column sheet number, where we were converting we just kept ending up with the wrong thing. We have 10 here. I don't think we're getting the wrong answer. I think we're just supposed to put 0 for any remaining. Maybe we're ending a little bit too early. So if we have any, if we'll say while power is greater than 0, then we'll just add the remaining bits. Add the remaining places. So we'll just do string plus 0. And then we'll add a test case for 16. Where is power ending? Is it already at 0? Oh, it's already at 0. I think I'm realizing my issue with these problems. This is the same thing that happened with the base 26 version. I think in regular hex you can't represent 16 except by going to the next place, but in mines you can represent 16. That's not possible. Because my other one had the same issue. Whenever the number was evenly divisible by the base, we were off. So I think the problem is in here somewhere. And we're translating something from to base 10. It's the place value times the base to the power. So 16 to the power sounds fine. Maybe it's just this version of building the frame of reference from this, like from the base like this, is just not something that makes sense. Maybe you just can't solve the base like this. I mean, maybe you just can't build the answer like this. I think I understand. I think it's this version is the right version. Except we should take away this equal sign, I think. This should be 15. Starting from the highest power, we're saying, then we do a for loop from 0 to 16, which is just 0 to 15. 15 minus offset, so we go 15, 14, and which down to 0. I think it's just this version doesn't work. I don't know why it doesn't work. I know the reason where we're failing is that when this version doesn't split value correctly. Like if you have 16, it should be 1 0 because that's how we count. But instead, at 16 to the 1. 16 to the 1, you can just put 1 and you get the value 16, which means value doesn't carry properly. Maybe if I remove let me do something. I just want to see. We'll just say plus power. I want to see what power is actually. Something's wrong. I'm not even getting anything close to what I was getting before. Right, so it's at the power of 1. So we should add the 0. We put the power up here, and then we subtract it from power. Oh my gosh. I guess it'll have to do. I can't believe we actually were figure it out. Our solution is not flames though. Let me see how much we can remove and this still makes sense. So I think you can. I guess we're going from the front to the back. So when we finally do calculate the number that fits, we need to put a 0. We need to fill in the remaining zeros afterwards. And we weren't doing that. Because the number can vary, we can't just fill in the remaining zeros after we place the values. Or maybe we can. What if we put this power back to 8, and then we can leave power minus equal down here. That, I think, just makes it reads more logically. And then the other thing, instead of adding a 0 here, what we'll do is just this. If product is less than or equal to num, then we'll push on a hash, the correct symbol. Otherwise we just push on a leading 0, and then we can reuse this block here to pretty much find the first non-zero index. And I feel like this should still work. Oh, no, wait. Oh, maybe not here. This would be in the for loop. Right now, we're just looking for a value. Pretty much, we need to I'm using power. What I'm really trying to indicate, the number of powers is the number of places. Basically, we'd like a string at the end that has 8 characters, but afterwards we'll pretty much remove all. We'll just remove all the leading zeros afterwards. So to do that, we pretty much just want to make sure that if string.length, so the first indice, hopefully we find a place for it. If we don't, it would just be empty, and then we'd say, okay, it should be that 8 minus string.length should be equal to power. Now if we do 8 minus 0, would it equal 8? Definitely want to do this after we subtract power. If it's not, then we'll just do string plus equals 0. if we don't add any character here, do this for, then we'd like to add a 0 because we'll subtract the power and then we'll do 8 minus string length, which would be 0. 8 minus 0 equals 8, which does not equal 7. So we'll add a character. This should now be wrong. So we should have a bunch. Okay. 2, 3, 4, 5, 6, 7, 8. This is convoluted, and I'm not going to remember this. I think we should just look at the solution. Plus, it's just simpler to move this up here. Then I have to add the bit back in about while power is greater than 0. I think we'll take it. So this would be constant time, I believe, since we're doing a specific set of operations. So power, which is 9 times the base, which is 16, so 9 times 16 operations. And then our string at max can be 8 characters, so I'd say constant space with constant time. But definitely I'm sure there's a faster way. I'm interested to see. I also think the reason why we can just do this, it looks like they were just taking the negative representation and printing it as binary, which is why the number, when it was printed as a signed integer, was -1. But as an unsigned integer, it was just FFFF. So we shifted it 0 bits with unsigned bit shift to pretty much just convert it to its unsigned version, and then convert that. There's also no So, if num equals 0, then return the string 0. Result is an empty string while the number does not equal 0. So let's just say they gave us 16. Do result equals map sub 16 and 15. We look at the first 15 bit, first, they take a look at the last 4 bits, map that to a hex character, shift the input to the right by 4 bits. Here, also using unsigned bit shift. What does num ampersand 15 do? I'm pretty sure this is masked. They're masking num with 15. I'm only used to masking num. I'm only used to masking with smaller values. Oh, you get 0, right? Because the bits wouldn't be there. So if we masked it with 15, then we masked it with 14, or actually just 8. I see. That's an interesting solution. Basically, just look at the last 4 bits and turning that into a hexadecimal number. I think that just works because hex lines up with binary. So I would hit this for 26. Maybe it would still be fine, actually. Well, maybe it wouldn't, actually, because you can shift it 4 bits over and it'll line up perfectly with 15. But you can't do that with 26. Example, num is equal to 4012. What is 4012 in binary number? Well, to convert binary to hex, we separate the binary in 4 groups. How to read 4 bits each time? We can use bitwise AND operation. 15 in binary is 111. If we do num in 15, we'll give you the last 4 bits. After each loop, we need to remove the last 4 bits. This approach can also handle the negative case. No bit manipulation. Unsigned int. Implicitly cast negative numbers. Negative ones turns to the maximum number representable. That's an interesting way to do it. I'm realizing we actually didn't have to use a map at all. We could just use an array. Or we didn't have to use a hash at all. Well, a number exists, convert it into base 16. We're going from left to right, so we need to reverse our result when we return it. Do string plus equal our array, our num mod 16, our num divided equal our array. Mod 16 will give you some number. If it goes into it perfectly, you'll get a 0. Then we divide it by 16. Unsigned int. Unsigned int. Unsigned int. I think we could fry Excel column sheet number now. So I see a couple of things I was doing very wrong. Oh, this is neat. I'm not convinced that this explanation makes sense. So first sign bit, -3 stored in 4-bit. That's true. Convert to unsigned 4-bit. Unsigned 4-bit. Actually, now I'm interested. Instead of doing what we were doing with here, like this, what if we just said num is equal to the bits flipped added 1? Do you still get the right answer? think this is why it wasn't working. Negative, when we flip the bits, we add one. Now we get the opposite of or the inverse of the number. We add both of them, you get 0. It also, I feel like the problem literally just wants you to convert the binary in the number to hexadecimal, which is what's confusing because I thought you had to do all this extra stuff, and you can just always bit shift it, unsigned bit shift it 0 bits to convert it, and you still get the right answer. I'm still a little fuzzy on the 2's complement stuff, though. Still a little fussy on it. So it's just interesting. 2's complement method is used. Yeah, I think I see. So that is cool. And I think in the future we're just gonna go with the modulus and division version, because that was a bloodbath. And then I'll reset this so that we already did it. So we have valid word abbreviation. This one has a lot of dislikes. So we know it's going to be a doozy. We have about 6 minutes. String can be abbreviated by replacing any number of non-adjacent. A string can be abbreviated by replacing any number of non-adjacent, non-empty strings with their lengths. The lengths should not have leading zeros. For example, a string such as substitution could be abbreviated as, but not limited to, S substitutio 10 sub 4 U4 12 Following are not valid abbreviations. The replaced strings are adjacent. Has leading zeros. Replaces an empty substring. Given a string word and an abbreviation aber. Given a string word and an abbreviation aber, return whether the string matches the given abbreviation. I think I understand the Apple A to E. Huh? A to E. I was going to say, okay, we're missing L. I don't understand when we can abbreviate and when we can't, though. A string can be abbreviated. A string can be abbreviated. String can be abbreviated by replacing any number of non-adjacent I think there's two ways to go. We can generate all the abbreviations and check if it exists, or validate error. First approach would take a lot of space, probably a lot of time. Second approach, I'm not certain. We can come up with all the validation criteria. One would be that all the letters used in the string would have to match given word. The substrings that are replaced with the specific numbers should be able to be added up. To sum the length of the word. For example, apple is 5 characters long. If you do A plus A, which is 1, plus 2 plus E, you get 4 total characters, which means they clearly can't be the same. This one, if you do I plus 12, do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? You get 13 plus IZ, which is 15, right? Plus 4 for Atio, and then 1 for N, which is 15 total, and you get 15 total. Right, oh yeah, 15 plus 4, we get 19, and then we get 20. So it does add up to match. That's one thing. But we just need to know that it's possible for it to exist. So I think we could go the validation method. We just have to make sure that the letters that are used are letters that still remain. And then I think we could validate this with a map. But we ran out of time for today. And actually I think today is day 120. So I'll have to make sure. Yeah, I think today's day 120. So that is a wrap for today.